you want to?
Sorry, guys. We're about to start. Okay.
Cool. Take 3. Fingers crossed.
Thank you.
Yeah, thank you. Thank you. Thank you. Who here was at BAS on Sunday, by the way? Okay, these might look a little familiar. But I did tweak some, so there's some differences. Cool. So a little bit about me. I'm on the engineering team at Alchemy. I've been there a little bit over 3 years now, and for the past about 3 quarters, I've been thinking a little bit about Web3 UX. We talked to tens of thousands of development teams, and a common theme is, hey, it's really hard for me to onboard new users. The limited market that I can address is not sufficient to run my business in. How do I make this easier to onboard more people over time? And a little bit about Alchemy is we're a Web3 developer platform, so we try to provide tools and services that developers might need in order to build dApps and other tools on top of Web3. So in the same way that kind of operating system let developers build on top of hardware and cloud computing build on top of cloud infrastructure, we try to build on top of Web3 infrastructure to provide a seamless platform and user or developer experience. Okay, so quickly, why are we here? Quick show of hands, who's read Vitalik's 3 transitions blog post or is familiar with it? Cool, seems like a good familiarity. But he argues essentially there's 3 main transitions that need to occur to enable onboarding more people to the blockchain. The first is moving to L2, so the L2 scaling transition. The second is the wallet security transition, and that is moving users from EOAs to contract accounts. We'll go into what that means a little bit later. And then the third is the privacy transition. And so we're kind of focusing right here on the second piece of how do we migrate more users to contract accounts over time. And the reason that that's important is, as we mentioned earlier, wallet UX needs to improve to onboard 1 billion people. And at the same time, self-custody matters. And as Antoine pointed out earlier, there's generally a direct trade-off between UX and self-sovereignty, and how do we provide a solution that checks both boxes. So today's agenda, why AA, what AA, how AA, but slightly more technical, and then we can tie it all a little bit together.
I like it.
So first, let's rewind to the 90s. This might probably, honestly, I'm aging myself being in this room, but will look familiar to some of you guys as an internet UX that was around back when you used dial-up modems and everything was super slow, and you opened and you got 30 viruses from pages that look like this. So UX was poor. End users kept getting compromised on the internet. There were not many security rails. It was kind of the Wild West. And also in the 90s, a Nobel laureate, I don't know, again, who's familiar with this? This is Paul Krugman. He's an economic Nobel laureate. He kind of called the top on the internet in the early mid-90s. He's there's not really anywhere to go from here. And also in the 90s, there was this concept of internet companies as directly opposed from real companies. So internet companies had unorthodox business models, as exciting as they were. They were unappealing to the biggest consumer spending markets, which tended to skew older. New technology provided more friction there. The UX was difficult and foreign. Scale and infrastructure was limited. And there were unclear legal frameworks. And compare this to the real companies like GMs. They sold cars. They were tried and true business models. Generations grew up kind of familiar with these products. There were years of legal precedence, and they were able to create products that served entire countries. But still, there was a little kernel in the internet that got people very excited. And today, I would argue that every company is an internet company. And specifically, what I mean by that is that all companies provide value to their users via the internet in some capacity. So even on the list before was Saudi Aramco, and you're that's not an internet company, but you can go to SaudiAramco.com, learn about Saudi Aramco, learn about their business, see where, as a vendor, you might be able to distribute their products, et cetera. And so they're able to provide some value to their customers and to their user base across the internet. So internet UX has come a long way in 3 decades, from the screenshot I showed on the left to some that you guys are familiar with on the right, which is Amazon. You open it without thinking, you can purchase products, they show up at your door, it's incredible. So how do we get from A to B? Also today, UX interfacing with blockchains is very limited, so I think all of you guys are probably familiar with this page. It's the problem that we're all kind of trying to solve is there's no way my mom is ever getting on crypto if she has to do this when she gets set up. So how do we improve this UX? Also today, the same Nobel laureate, Paul Krugman, called the top on cryptocurrencies because it goes exactly in the opposite of long-term trends. 0 for 2, Paul. And today, there are distinction of crypto companies versus real companies, where again, crypto companies, difficult legal frameworks, difficult scale and infrastructure, exciting but unorthodox business models, and unappealing to the biggest consumer spending models. And the real companies, which were like the internet companies of the past, have evolved not to just like country scale, but like global scale. Still, there's a kernel that people are very excited about blockchains. So how do we get to a future in which every company is also a crypto company? And again, that doesn't mean they have to be crypto forward, but how do they provide value to their users via their applications? And that can be predicated on crypto rails. So how do we get away from this page to the types of UX flows that developers and end users are more familiar with? So going from like a seek recovery phase to this recover with Google, or this Metamask checkout flow to something like Apple Pay that millions and millions of users are all familiar with. So I argue, and if there's one thing you guys take away from this, is that we can solve a lot of these UX problems with smart contract accounts, and that account abstraction enables smart contract accounts. Account abstraction is a little bit of a terrible name. We'll dig in specifically into what that definition is later. But if you were to take away two things, let it be these two things. Smart contract accounts enable better UX, and account abstraction is the infrastructure that enables smart contract accounts. Whoops. So quickly, we'll dive into the technical underpinnings of account abstraction. We'll dive a little bit later into what Alchemy is doing in this space, and then we'll start tying it together back into like some of the high-level ideas that we think are really promising here. So there are two kinds of accounts, as we learned a few times now. There are EOAs and there are smart contract accounts. EOAs are fully controlled by a single key that can never change. If you lose the key, you lose the account. It has very hard-coded validation rules. So on Ethereum, that validates a signature valid along what's called K1 elliptic curve. It validates the user's account, it validates their balance, and that's about it. And you can never change that ever. And like contract accounts can have like whatever access rules they want. So you can use different elliptic curves, you can use other cryptographic schemes, you can impose other types of constructs into what defines a user's account, such as things like account recovery. So in general, it would be really good if you could have contract accounts instead of EOAs. However, on Ethereum, all blockchain activity today must be initiated by an EOA. This is a reason that Argent moved to Starknet. So Starknet has native account abstraction. It's not a limitation there. But if you want to address the biggest developer ecosystem, you're limited by the EVM. And the EVM requires all transactions initiate via an EOA. So maybe as an alternative, let's introduce a new actor we'll call an executor. And instead of you using your EOA, the executor can use their EOA to abstract you away from your smart contract wallet. Cool. So it could work as follows. A user says, hey, executor, please send this message to my smart contract account. The executor says OK, and then sends the message to the account, executes on the account, like happy ending, right? Not quite, because in this model, the executor is stuck paying for gas. So in the Ethereum model with an EOA, there's always a gas fee associated with every transaction. And in this model that we proposed earlier, the executor is stuck paying this gas fee for the users. That doesn't quite seem right. How do we improve that? So what if we just say, hey, I promise that I'll pay you back for gas if you execute this message. We're in Web3, like it's all about trust but verify. We want to rely on cryptographic primitives and not, hey, I trust that you do this. So how do we enforce this on chain? In other words, the executor, quoting Rihanna, wants its money back, and we don't want to just rely on the trust from the user. We want some like concrete primitive in the protocol to enforce this interaction. So to that point, we can introduce the entry point. And the new flow now is the user sends a message to the executor. The executor sends this message to the entry point, which executes the message on the user's wallet, and then also makes sure there's enough gas left over to pay the executor back for using its EOA. So atomically, it'll make sure that the message executes on the wallet and pay the executor back for these gas fees. Cool, so now we have a slightly better flow. And as we're moving, we realize, hey, this executor could probably do this flow for more than one user. Why is it doing it for just one user? So why don't we rename it to a bundler? And now it can do a lot of these flows for a lot of users and kind of aggregate a lot of these account abstraction transactions into a single transaction and post later. So the new flow is like this. The user's like, hey, bundler, here are all my messages. The bundler takes all the user's messages and sends them to the entry point. The entry point then federates them out across to the user's wallets and makes sure that for each user it has enough gas to then pay the bundler back for executing this transaction. So now you have like kind of a working flow of how do you send funds to a user's wallet and get the bundler reimbursed for these actions. It doesn't address a core issue of UX and blockchains, which is gas. So like in this model, someone, namely the user's wallet, still has to pay for gas on every transaction. Like what if they don't have gas? How do they get started? So we're building some of these bundlers. We'll talk a little bit about the specifics of that in a little bit. But as mentioned, like this gas problem is still a huge problem. New users get started, they can create an account, but then they can't send a transaction until they have gas. And to get gas, you like go to Coinbase, you KYC, you wait 3 days, you figure out how to bridge, you get the network wrong, you get super pissed, and you never use crypto again. So what if we can abstract this away entirely? So in the 4237 spec, there's an actor called the paymaster, and that's exactly what the paymaster does. So the paymaster can cover the gas fees instead of the user's wallet. So we're writing some of these as well. We can go into a little bit about that in more detail, but honestly, these are less interesting. And now we have this like full flow as defined in ERC 4337. So users send all their messages to the bundler sends them all to the entry point executes them on users' wallets, and then instead of collecting the gas from the user's wallet, collects from the paymaster, providing the logic all works out. And everyone's happy, users can get started with no gas, bundler gets reimbursed for its actions, and we have kind of a coherent system that works for all users here. So that's kind of like a high level of the 4237 flows. A couple things to call out. So I think this was a question that Antoine fielded earlier. Sorry that the text is a little bit small here, but I think there's like a couple different parts of this process that need to be distinguished. So one is the actual smart account. That's the user's account on chain. And that has a bunch of rules around like, what do I execute? How do I execute it? Who has this permission to do that? And then at the top level, there's the key management. And like in blockchains, every single transaction still needs to originate with a signed message. So like there are still keys living somewhere. Account abstraction alone does not solve the key management problem. It can help make keys more redundant by giving you multiple keys and giving them scope partitions and even letting them use other signing schemes. So as I mentioned, Ethereum uses the K1 elliptic curve. It was borrowed from Bitcoin, and Bitcoin picked that because they're like tinfoil hat, government has a backdoor, can't use anything popularly supported. But like there's a lot of really good popularly supported curves. So like anything NIST supported will have support from the hardware on your device. And so what you can do with that is if you validate a different elliptic curve like the R1 curve, you can use your phone as a hardware wallet and sign transactions with things like Face ID instead of relying on like an EOA that is hard to secure because you can't use the secure enclave. You can also use things like post-quantum signers if that becomes necessary. You can use things like BLS signature aggregation to push costs on an L2. Won't get too much into that now, but I'll have to answer questions about it later. Cool, and then I guess this is like intense day. So back to Dan. If you guys were here the other day, Dan gave a good talk on why intents are PsyOps. So bringing that meme back. But there's like a very light user intent model here where like the user just wants to execute a transaction. Like they don't care about gas. So how do we abstract gas away from the end user and give them this like this transaction object where like some other actor is incentivized to cover gas on their behalf, and that's kind of this paymaster entity that we covered earlier. So the paymaster can enable a gas abstraction for end users, enable them to either get like free transactions, so they're entirely sponsored, or sponsorships in other ERC20 tokens. So like if you're a game, you can pay for gas with like the token for my game, or you can pay for gas with USDC or something else. Cool. So I mentioned earlier that we're building a bundler. We called it Runler because we suck at naming. It's a Rust bundler. I know, super clever. Naming's hard. So all my slides up to now were pretty nice. After now, like, no, don't judge me for this. But here we go. So what is Runler? Runler is a Rust 4237 user operation bundler. We're drawing a lot of the design principles from Reth, which is Paradigm's new Rust Ethereum client. It's designed to be highly modular and leveraging the latest and greatest in the Rust Ethereum ecosystem, which in general has been designed from the ground up for performance. So as to that point, there's 3 core components. There is the user operation mempool. It's stateful. And then there are 2 stateless components that can scale horizontally on top of that. There is the RPC server and the bundle builder. And you can run this all in an integrated mode on a single machine with 0 copy, so it just passes around references. You can also run this on different machines for horizontal scaling and using gRPC as an interface. We've been making heavy use of Ethers RS. We're going to switch to Alloy, which are like some of the newer projects coming out of the Rust ETH ecosystem. And we have some pretty novel gas estimation techniques for user operations. So we actually implement binary search and solidity to kind of account for what's called the 164th rule. And then last thing, we've spent a lot of time around bundle building to like reduce the gas overhead, make it easier for things like BLS signature aggregation moving forward, and handle all the denial of service rules defined in 4237 to protect the bundler. So we're going to be open sourcing this pretty soon, a little bit more than that in a second. When Runler, so we're actually currently live for Alchemy's managed services. So if you guys want to get started building on the bundler, you can do so via our endpoints. It's across Ethereum, Arbitrum, Polygon, Optimism, and Base right now. We powered CyberConnect's Airdrop last week, which I know is a 7x portco, so awesome to see that. We have a long checklist that I promise you has more check marks at this point of us getting ready to open source it and just making sure that it's like clean and ready for developers to onboard to. Where Runler, so it's on all the non-native AA EVM chains, like Starknet, as mentioned earlier, is awesome. You don't actually need a bundler. There's actually a lot of things that are bad about the bundler. We can talk about that in a second. So Starknet makes like, we don't even want to bother with that. We're already not EVM compatible. Like, let's just build it right from the get-go. For the EVM chains, you'll need a bundler if you want account abstraction, or you can use like legacy systems like Gelato. But the thing with the bundlers, it's one, standardized, so you get some kind of like ecosystem compounding benefits, and two, once it has a mempool, will be more censorship resistant than anything that is out there today. How and who Runler? So we're still benchmarks pending, but we handle this airdrop pretty well. We've been load testing over 1,000 reads per second, and the live use cases were about 25 writes per second. But honestly, all of this is kind of constrained by the underlying network. So reads mainly fan out to the like nodes that power the bundler, and writes are going to be limited by the amount of gas per block in the underlying network. So we actually had a bug last week, 2 weeks ago, where we were creating bundles that use more gas than Optimism allowed per block. So we had to go and fix that real quick. It's currently a core Alchemy team of 4 engineers, and we're hoping to get some open source contributors on soon. We've already talked to like a few early interested parties to get like early exposure before we full open source. If that could be you, come talk to me after. There's a few limitations of bundling in 4237. So it's like a bit idiosyncratic that the block builder is separate from the bundler. A lot of the 4237 rules exist in place to protect the bundler, and those wouldn't have to exist if the bundler can guarantee that transactions won't revert on-chain, which is a power the block builder has. So over time, we see this moving towards native AA, where hopefully some of the optimistic L2s can start thinking about what this looks like before we decide to enshrine it in Ethereum in probably like a 5-year timeline. Cool, looking forward. So we're cutting the public beta release early mid-September. This is like the open source cut. We've been working on P2P specs with folks like Biconomy, as well as other folks writing bundlers and the Ethereum Foundation to make sure that it's designed thoughtfully and scalably and can handle this ecosystem load moving forward. Again, kind of leveraging all the latest and greatest from Rust Ethereum. So we want to add some like custom simulation tracers straight into the ref binary. We want to experiment with things like AA-Ref, where we can support both non-AA and AA and have like a top-of-block user operation bundle transaction, as well as a bunch of regular transactions after it, and like various improvements to the node client itself to better support account abstraction infrastructure. We also, not on here, we've been working a lot with the Chain Foundation, so like Arbitrum, Optimism, Polygon, et cetera, to better support AA in their ecosystem. So we passed AIP2. It's an Arbitrum improvement proposal to support conditional transactions on their sequencer, which is like another way to better protect these bundlers moving forward. Cool, using Runler. So as I mentioned earlier, you can get started on it with Alchemy today. It's the same API endpoint that you use for any other request on Alchemy. We're going to be open sourcing it soon, so if you want to run it yourself or you want to run on chains that we don't support, like that's totally going to be an option. We're very excited to get this in the hands. It'll be a copyleft license, so feel free to fork it and modify it as you want. Any commercial use cases will have to remain open source, is the only requirement. And there's generally a lot of complexities to all of these flows around like fee estimation and like constructing accounts and like knowing how to like there's a concept called a counterfactual. So you don't want to deploy account until its first transaction to save for gas. The SDK will like abstract all this stuff away from you and just make it a very simple developer experience. Okay, cool. So that was like a bit of a technical deep dive. Quick lift up and like back into the tech and then out of the tech for reals. So what does this enable? Argument is this starts to enable these types of use cases that users are familiar with today. And so, oh, is there a missing slide? Oh no, I'm missing a GIF. Oh, it's here. All right, it's not even that good of a GIF. I hyped it up. Anyway, so we can enable this with what we're calling modular smart contract accounts. This is being worked on by a lot of folks, not just Alchemy, and we're really excited about this. So powering this is in ERC, so it's ERC 6900. We've been working on it for about 2 quarters now. We recently added Yoav from the Ethereum Foundation as a co-author. He's the one behind 4237. We're working to start expanding the author set to other teams too. And like the whole idea here is creating a modular smart contract account. And the reason that you'd want that is because Vitalik said so. No, just kidding. But he did say that. And the reason that we want to do that is to maximize flexibility for dApp developers while optimizing for extensibility, composability, and security. So ideally, instead of everyone rolling their own account implementation, as a developer, you can kind of mix and match which plugins you want to provide the best application experience in the context of your account by defining this user stack on chain. And so you both provide developers this like secure composable building block primitives, and you also reduce developer lock-in to specific account limitations. So any plugin can work with any account. Okay, and so like defining a modular account this is a lot of like text. There's validation functions, there's execution functions, and there's hooks. Validation functions validate authenticity, so you can like validate a new signature like the R1 curve. Execution functions execute any custom logic allowed by the account. So like this might be something like a cross-chain transfer. And hooks execute custom logic before and after execution functions. So an example might be, hey, I never want this NFT to leave my account. If it ever leaves my account, revert the transaction, and you can use that to like safeguard your $100,000 NFT on your account. The overall architecture here is loosely based on Android's permissioning system, where this ERC defines a way for the account to know how to install and uninstall plugins. There's like an iteration coming out in about 2 weeks together with reference implementations that also define like some of the security concerns around the plugin and how to like properly permission this interface. Buzzword bingo. I guess we already mentioned intent, so it's like not that climactic, but there's a lot of buzzwords in crypto. I think we're, as a community, very bad at naming things. So this is just kind of an example of that. But I think long-term, how I see ERC 6900 shaking out is that it facilitates kind of a marketplace for intents, where right now, like for a user to do something in crypto, it's very imperative. Like, oh, like I want to swap, 1 ETH for like 1,800 USDC on Uniswap on Arbitrum with like this slippage parameter, and like the whole concept of intent is like, hey, I just like want to swap my 1 ETH for as much USDC as possible. I don't care about the slippage. I don't care about the chain. I don't care about the protocol. Like just give me the most USDC. And you can start packaging a lot of these intents into like hardened plugins on chain. So like with the example I gave earlier with like the, hey, I want virtual cold storage on my NFT. Under no circumstance should it ever leave my account. Instead of figuring out how to do that yourself, you just like go install this like virtual cold storage plugin to your account, specify the NFT, and any transaction that tries to trade that NFT will revert. You don't really have to care how that works or why that works. You just have that guarantee. So we start moving towards this more declarative intent-based usage of the system. Is it an intent? Is anything an intent? I don't know, but it's moving higher up the stack in terms of the abstractions provided. Cool. So in this way, like you can start also having dApp developers define the application experience based off of the plugins they provision their users. So like if a user onboards via an NFT marketplace, they might want to provision a stack for their signer. You might even have like a signer per dApp, and that signer has permissions to do like account recovery. It might enable social login higher up the stack at the key management layer. It might have like role scope signing. So like this one key only has permission to like interact with NFT contracts and trade NFTs, but it can't go like sell everything I have on Uniswap. And like similarly, like a payment company might like provision a stack for their signer that's like cross-chain stablecoin payments, so you can abstract away the network. It might require a like precondition hook that every transaction checks for a KYC credential on the account, and it enables things like paymasters for USDC. So it creates a closed ecosystem around USDC, and they pay for gas with USDC. And like gaming companies might want to create a signer for their stack that enables them to pay for gas with their in-game token, and also provides session keys so they don't have to sign transactions on like every single in-game action. Cool. So now taking a step back, tying it all together. So what is account abstraction really? Terrible word again. What happens is like from the protocol perspective, we're abstracting away support for EOAs and smart contract accounts. Like Ethereum natively only supports EOAs. This abstraction's in place to like make it from the protocol's perspective. It can now support both without really caring or changing the core protocol mechanism. So looking forward over time, we want to wind up in a world like StarkNet today, where every account is a contract account. There's been a lot of exciting updates on that. So the EF actually published an EIP for I think they call it like the upgrade transaction. It's like a one-time transaction that in place upgrades EOAs to contract accounts. There's been like a stalled out EIP for native AA on Ethereum. I think realistically that's a few years out, but I'm like excited to start working with L2s and governance to like iterate on some of these concepts on those ecosystems. And so taking a step back, account abstraction enables developers to provide values to their end users while also abstracting away the underlying crypto rails. So account abstraction is from a protocol level. Protocol is getting account abstracted, and then the users are also getting abstracted from the account. So just account abstraction all the way down. And that kind of gets us to this future where, like we saw with the internet 3 decades ago, hopefully on a sooner timeline with crypto, we'll get to a point where all companies could provide value to their users via crypto rails in some capacity, even if it's not a super crypto forward experience. If you guys want to learn more, check out our website at alchemy.com/account-abstraction. I think that QR code will link to it. I'm probably Noam on Twitter and Telegram. I'm happy to chat about these things anytime. If you guys are building on AA, and you're here, message me, tell me you're here. We'll get you set up with support teams and credits and stuff. Would love everyone's feedback. But yeah, happy to take questions if there's anything else.
Usually, in practice, if I want to build smart contract wallet, so who going to deploy Bundler? So it's going to be me as a smart contract developer, smart wallet developer.
Up to you. It's kind of like the Ethereum node ecosystem today, where you can we encourage people to do it. It's supposed to be distributed and decentralized, and if you want to do it, great. We'll also provide managed services if you want to get started with less hassle.
Yeah, I'm asking because there is a legal problem here. Since bundling from financial perspective, this means batching transaction, which requires money service business license. And the whole thing creates a kind of issue.
So it's actually not a money. I'm not a lawyer. Don't quote me on this, but it's not a money service business in the same way that layer 2s are not a money service business. Essentially, because all transactions are still signed by the user's client side, there's no way for any bundler to do anything to impact the execution of that transaction. It's more of a pipeline than it is like a money service.
Yeah, it's kind of helping to facilitate.
Yeah.
Basically, do you have legal opinion on somebody who can do this in the
I don't have a legal opinion. Our lawyer has a legal opinion.
I'm asking because it's clients needed, because I cannot do this in the US without legal opinion.
Yeah, so we're running these services in the US as well, say, and our lawyer feels comfortable enough about that, but I don't want to put him on blast. There's everything in crypto is a little bit of a regulatory gray area right now, so there's no hard yes, hard no. We're kind of predicating this a lot of the L2's operating model too, where they also accept transactions, post transactions, and they're more of a pipeline, and so are we.
Yeah, the same with Paymaster. So
yeah.
How do you see the MEV being extracted from the bundler? Or, did you see a system on it?
Asking the big questions.
Or going with a block builder.
Yeah. So we at Alchemy, our core business is RPC node infrastructure. So we have a good amount of order flow, and our stance is we don't touch order flow. If you send it to us, you either tell us to send it to the Flashbots and we'll send it to the Flashbots, or you tell us to send it to the mempool and we'll send it to the mempool, but we don't have an opinion on it. That's how we're going to run our AA infrastructure. There's obviously interesting problems with AA and MEV. The bundler is essentially a mini block builder, and there are things you can do around extracting value from that. We're not entering that space, but if anyone starts setting up searchers on the mempool in the bundler space, that's a totally viable thing to do.
You mentioned something specific, like server with their airdrop, something like that. What exactly did they?
Yeah, so they had their token airdrop. Part of it was they deployed everyone a contract account, let them claim Cyber, and then there was often also a transaction to sell Cyber move Cyber to Binance. And so we saw a huge spike of activity and a couple 100,000 new accounts deployed for 4337 on Optimism.
Sorry.
Yeah.
So what their experience they had? They had a one-click thing and they were everything done? Or?
I believe they let you use your EOA as a signer. So they use their Metamask, but they got a contract account behind the scenes.
Okay.
So it wasn't a fully embedded flow. They still used Metamask.
Fully embedded to connect with the Binance thing.
It was not fully embedded, no. Okay. So they used Metamask as the intermediary here. I'm happy to dive more into that if you want to chat.
You mentioned conditional transactions on sequencers right in one of the slides. Can you explain that a bit?
I mentioned what? Sorry.
Conditional transactions on sequencers.
Oh yeah. So as you guys are familiar with, if one of the issues is the bundler is super sensitive, it's a fragile old lady of a software piece, and essentially there's a lot of ways to attack the bundler. Where if you get a transaction in before the bundler, and then it submits its transaction, and the transaction then reverts on chain, the bundler has to pay for gas fees, and because the transaction reverted, it's not getting reimbursed for those gas fees. So there's a way to attack the bundler by front running it essentially, and all the simulation rules in 47 are designed to protect the bundler, but you can still front run those things. And so the conditional transaction endpoint on Arbitrum, and we're pushing on Polygon and Optimism too. And it's essentially what you get with flashbots is like, if this memory state is what I expect it to be, so it's like a precondition check. If this storage hasn't changed, execute it. If it has changed, don't do anything. And this way, it gives you like an atomic way to like not try the transaction if it's going to revert on chain.
And how would it work for any L1 like Avalanche or UC?
How would it work?
For any L1, for example. Like
It can't work. It only works on sequencers right now. Polygon's running into a lot of weird issues because they're proof of stake, and there's like some weird DOS issues if you expose it to in the public mempool. There's a thread on like the Polygon equivalent of ETH Magicians to discuss. It's PIP. If you look up like Polygon proposal conditional transactions, you'll find it. But yeah, there's like folks calling out the DOS conditions, and then there's like in parallel, how do we do this sustainably? They're landing at using private mempools, which is kind of similar to flashbots.
What has been your biggest challenge while building the bundle? Like I read your article about gas optimization. The gas estimation, I know it's been tricky, but how do you part of that?
Yeah, that like by a mile has been the biggest challenge. Gas estimation for 437 is a huge pain in the ass. Still is. He's referencing a piece that one of the tech leads on the team wrote. It's 15 pages about gas estimation 437. The fact that you can write 15 pages on gas estimation is like kind of sad. So there's a lot of problems there. Big one is like all the L2s do gas fee markets slightly differently. So there's a lot of weird nuances the bundler has to account for. Another one is like faster moving blockchains like L2s move the fee market very quick. So if you like estimate gas at 0.1 and then submit the transaction at 0.2, like it's very possible that the gas market's risen and the transaction will be just stuck forever in the mempool or for a long time in the mempool. And then there's just like a lot of like essentially the bundler has to predict how much gas you will spend in order to know how much to charge. And there's like a lot of weird things that L2s do in terms of like accounting for, there's like the L2 priority fee, the L2 base fee, and that's derived from the L1 data availability costs. And those are like kind of hard to measure from L2.
How do you protect against recur attacks in kind of?
Uses a nonce.
Okay.
Yeah.
So you have to write, as a developer, you have to write a nonce.
It's in the entry point now, right? Entry point at this point, yeah.
I mean, extra for it.
Yeah.
Okay. Have you taken any measures against front running of your bundles?
No, we were like, I don't know why. I don't know what stopped.
big problem or it's not like
It's like a minor problem on Polygon, but like on L2s it's very hard because there's no public mempool. On Ethereum we use flashbots. Sweet.
Yes, thank
One more question.
Sorry, a short question. What is the incentive to run the Runler?
So the bundler like it accepts user operations at gas price 1, and then posts user operations at gas price 2, and then it gets the spread of the gas. So it gets like a little bit of gas in exchange for the work. It's like pretty hard to optimize this, honestly. Like we try to run it near zero, but it like, has a big spread. We as Alchemy, we view this as a way to 10x the ecosystem. So we're just like trying to get people on because we think this new UX will like get more people in crypto, and that's just like good for business. But then we have like our core like CU-based model where like certain requests, depending on how computationally expensive they are, like reflect in charges for developers. We have like a pretty big free tier, so like most every application on AA now can probably just fit in our free tier.
Thank you so much.
Yep. Thanks, y'all.